Hi folks, Mr. Lowe is going to talk to you today about the IA and some things to hopefully help you in this process. First of all, a couple of documents that you're definitely going to want to get are these two, which, and in fact, I'll probably email these to you, at least here in 2020. This checklist as well as this rubric. Both of these actually convey a lot of the same information. This is the official IB rubric. This is just maybe has a few more details and ideas about how to execute that rubric. And then there's some other stuff here that you might want to grab while you're there. There's free software. Well, it's not free, but we have a site license for it because we've purchased it. It's called Logger Pro, and I think we've used it before. And it's primarily software that's used to gather data with some tools. Now, of course, most of us in 2020 are going to be doing this without doing an actual experiment. So still though, the software is really good because it's really good for scientific graphing. And I don't have time in this video or in general to walk you through that process, but there's some instructions here and things that you can work on to help you make those graphs. If you're not going to use Logger Pro, you can use Excel, you can use Google Sheets, but both those have significant disadvantages when it comes to graphing data in a scientific way. Okay, so what I want to do first is just give you a quick overview. I did some of this stuff in last spring when we were in remote learning, but I want to just kind of go over a quick overview again, remind you of a few things, and give you some hints and tips along the way. So just a quick reminder here. So this is going to end up being a 6 to 12 page thing. Historically, if you're doing an actual experiment, usually the problem is keeping it under 12 pages, but it'll be interesting to see how this goes with some of the database IAs. It's typically 24% of the grade. I think that's going to be a little bit different because we don't have to do paper 3 this year in 2020. You're going to turn in a first draft of your IA before winter break, and so I can give you some limited comments on those. And by the way, make sure what you turn into me is very complete, like, yes, first draft, but think of it as something that if emergency came up or something, basically it should be your IA, right? And then we're just tweaking it between the first draft and the second. Not huge changes, because I can't comment on stuff that's not there. So if it's very incomplete, that's going to be a problem. But we're going to turn that in before winter break, as I said. And we're going to turn into turnitin.com. Then typically what happens is I report the scores to Mr. Jones. I just say this person got a 12, this person got a 13, this person got a 17, and so on. And then 5 or 6 IAs get randomly selected from that bunch, and they're sent in for moderation, where a IB moderator will look at them and either adjust all the scores up or down based upon those. Now, I've never gotten moderated up, always down. Typically somewhere out of 24 points, somewhere between 2 and 3 points. So if I give it a 17 out of 24, the moderator thinks it's a 15 out of 24. Now, last year, of course, we didn't have tests, and it ended up that all the IAs were sent in, and all the IAs were graded by an IB moderator. So who knows what will happen this year. There's 5 categories. It's personal, and I'm going to go over these in detail in a little bit, but personal engagement, exploration, which is basically background information, analysis, evaluation, and again, I'm going to go over these in a little more detail in a minute, and then communication, which is kind of an overall thing. It's graded holistically, so in other words, you might meet your personal engagement score, not necessarily in the introduction, but somehow in the IA as a whole. It depends on where the information is found, or where basically you could earn points from any category anywhere, technically. This is a little section of the IB rubric. So personal engagement is worth 2 points, and so basically in each one of these categories, I'm sort of deciding that you're in either the 2 mark band, the 1 mark band, or the 0 mark band. Now, it's not 6 points total, so I don't give you 2 here, 2 here, 2 here. To give you another example from the exploration, it's what's called a best fit approach. So For example, maybe I think your topic is, oh, that's about a 3. Maybe I think your background is maybe a 4. Maybe I thought the methodology and safety were both 5s. So maybe I think, well, overall, really, it still is a 4. And it's just the best fit in terms of what band that you fit in. You don't necessarily need to be perfect to get a 5 or a 6. So you don't necessarily need to completely nail all of these to get a 5 or a 6. But so, it just kind of depends. Honestly, it's going to be a challenge to grade these database IAs, especially for me, the first time doing it. So we'll see how it goes. These are the typical cut lines. In theory, these could change, but you can see that out of a 24, you need less than a 50% actually to get a 4, and 11 out of 24. That's typically how it's gone in the past. It's usually pretty close to this. So, as you see maybe some of your scores and you get a 12, that's actually not too bad. At least it's a passing score. So before I get into that, I've popped up here the more complete. So this is what the IA rubric the IB rubric that I mentioned. This is it. So again, we can see up to 2 points for personal engagement, and then the main 3, I would call them, are worth up to 6 points. Analysis is split onto 2 pages here, so make sure you keep an eye out for that. And then communication. So I also have a checklist, and the checklist I have incorporates all of this information. So in theory, if you follow the checklist, you should be meeting the highest standard of this rubric, but I would certainly also recommend that you look at this rubric very carefully. And of course, we're shooting for the 5 and 6 mark band every time. But the checklist looks like this. So I actually did modify this in 2020. Let's make that change right now. So some important things here as far as submission requirements to take a look at. These are things that either are part of the communication score or just kind of part of the necessities for doing the assignment. You're supposed to have a title page. If it really comes down to it and you need that extra page, we can cut the title page, but you're supposed to have a title page. You definitely need in-text citations. So I don't have time to teach you guys how to do citations. I mean, you did your EE, right? You did do your EE. Whatever you did there, whatever citation method you did there, do it. It's the same thing. Academic papers need to be cited. It doesn't matter whether it's a chemistry IA or a EE or any kind of report. You need a citation system. Do it in the first draft. Okay? It's way more work to go in and put these citations in after the fact. All right? Do it the first time. Do it the first draft. As I mentioned, 6 to 12 pages long. That's total. And what can typically be the problem in a real IA is data tables and graphs take up a lot of room. So it actually can be a challenge to get it under the 6 to 12 pages. There's some things, I don't know if it's going to come up relevant this year, but you could in theory, if your thing was too long, you could maybe append some information to like an appendix or something like that. But the monitor does not have to read anything past 12 pages. That's important to remember. You should have page numbers in there. You should not have identifying info. Don't put your name on it. You should save it as your name, like in the file name, but the actual IA itself should not have identifying info. But this stuff is just communication stuff, which we'll get into in a second. So I've broken this down to different categories, and so again, the IA is graded holistically, so things don't necessarily have to fit into certain slots, but you're going to have some kind of introduction and background, and this is mainly going to be personal engagement and exploration. You need a focused problem or question that should have units of measurement if possible. Why did you choose doing this? Student shows interest, significance, initiative. Don't make up things. Sometimes I'll read just the corniest, like obviously completely made up reasons. Students will say, "Oh, I've been interested all my life in this topic," which ridiculously, it's silly. So don't make up things. You can, if there was something that spurred your interest, you can talk about that, but just don't make up things and don't oversell it, or it ends up looking really stupid. So just tell the truth. Yes, personal engagement is part of your score, but don't fudge it. So yeah, you need cited stuff. If there's chemical reactions going on, which in the case of most of the database IAs, there's not going to be, but if you're doing a sim or an actual chemical reaction of some kind, those reactions should definitely be in there. Now here is where you can get personal engagement without necessarily pretending that you've been interested all your life in, viscosity or something like that. What choices did you made what were the choices that you made as you did this investigation? Like if it's a real experiment, this is easy. Like, oh, I realized when I did the experiment I had to make this, that change, and all that sort of thing. Or even in the process of all the drafts. Or maybe when you actually start doing some really in-depth research, you realize you have to change things a little bit, change what you were looking at a little bit. So any sort of things like that you change or think about as you're doing the investigation, you can put that in there and that can give you personal engagement scores. Experimental design, now this is, what we would think of as a procedure. So if you are doing even a sim or a real-life experiment of some kind, make a detailed procedure, write it in a step-by-step fashion. Avoid personal pronouns. This is not an IB requirement, but you never know if some people in the science world get really persnickety about including personal pronouns. So it's probably best just to not include them anywhere, just in case the moderator's got a beef against it. So in other words, a beaker was massed on an electric balance. 20 grams of whatever chemical was added. Like, that's the sort of language. Don't write it like a command, like put 20 grams of salt in a beaker, like you read in when you get instructions on a lab. Don't do that. Talk about what you did, the steps that you took, and all that kind of thing. It needs to be detailed and all that kind of stuff. I'm going to talk more about modifying this to a database lab later, but you need to be detailed. Sizes of apparatus need to be included. Even in the SEM, to what degree it's clear. Like if you're using Yinka or something, you can talk about the size of apparatus. If that's whatever is relevant, even with the SEM, whatever information you could give, it should be there. Basically, somebody should be able to repeat your experiment exactly. So even if it's a SEM, what would they have to do exactly what you did? So we're going to have data tables. We're going to have some data processing. And some of this stuff is basic, right? Like you need a title. You need not only data you gathered, but if you need calculations, you should put the results of those calculations in a data table, some kind of data table. Uncertainties need to be included. Error propagation if you do any calculations. Qualitative data and observations. So obviously a little more difficult if you are doing a database. For a database, you may not be doing a ton of calculations for a database lab, but we'll talk more about that in a second. So mainly here, if you're doing any kind of sim or actual experiment, make sure that all the raw data is there. Don't leave stuff out. And just do the normal things that you know already that a data table needs, units and all that kind of thing. In a perfect world, we're going to have a graph. In a perfect world, that graph has quantitative information on both axes, so we can make a scatter plot and we can make a trend line. That's what we're hoping for. Now, it's not possible with every type of IA, but that's what we're hoping for. But again, we know a lot already about how to make a graph. You should have things scaled properly, a title, units, of course. We talked last year, it's been a minute, about R-squared values and things like that. You could consider other types of trend lines other than a linear trend line, and this is why I think especially LoggerPro offers some really great analysis options when it comes to graphs, that software that I mentioned earlier that you might want to get. And basically what we're trying to see is there some sort of mathematical relationship between these variables, and we should comment on that. And then again, uncertainties, error propagation, if we do some calculations, there definitely should be some appreciation of the uncertainty even on the graph. You could put some ranges on there. If you know how to put in error bars, which is something you do in LoggerPro, that's something that you can consider. So your conclusion, this is going to be in the evaluation section. These items here, don't think of these as a thing, like you just need to hit every one of these items in order or anything like that. That's not necessarily true. There's a lot of overlap between these things, and you just want to make sure that as a whole the conclusion meets the rubric to the best that you can. I can't stress enough how important it is to keep in mind the chemistry, okay? This is a chemistry IA. We should be talking about chemistry in this conclusion. I've read a shocking number of IAs in the past that chemistry is like barely brought up in their conclusion, and so that's a big problem. This is particularly true, I think, if you have a database IA. But we want to basically answer the question in the RQ, how did this experiment address the RQ? You should justify by the data, don't overstep your data. We're talking about the trends in the data, in the graphs, anything like that. Is the slope meaningful? Is there anything meaningful in the trend line that we can talk about? How does this link to currently accepted chemistry theory? Now, this is definitely a little more difficult if you're doing a database IA, but if you did an in-person experiment and it didn't quite work the way that experimental theory would predict, we're going to bring that up. Compared to an expected result, again, hard to do in a database IA. We should cite sources as usual, though. Random uncertainty, what is the significance? Now, remember, random uncertainty really just comes from the measuring devices used. You can talk about the size of the error propagation. What is the size of the uncertainty compared to the value that you're measuring? Really think back of, and if you have questions or questions about the differences between random uncertainty, propagated error propagation, and then systematic uncertainty or systematic error, let me know. Assumptions. So, are there underlying assumptions inherent in what you did that might cause things to be incorrect? For example, assuming chemicals are pure, for instance, when they might not be 100% pure. And then, so this last part is something that needs to be done basically completely differently, depending if you're talking about whether you did an in-person lab. Some simulations do have certain errors like built into them. Heat loss, for example, things like that. But what are the weaknesses in the investigation that may have caused problems? We need to be specific. Things like we may have measured more carefully. We need better equipment. That should be avoided. We should be talking about specific things. And again, if an in-person experiment is done, or I should say just some sort of actual experiment is done, how did the problems in our lab actually influence the results? Did they cause things to be higher than they should have been, lower than they should have been? So an appreciation of the direction of influence. So that's kind of the strengths and weaknesses. And this all goes together with error types and all that sort of thing. So as I said before, it all kind of overlaps. So suggestions for improvements. So if you were doing an actual experiment, are there things you could change about the procedure that would directly impact these weaknesses? And then we also need to talk about extensions, which is a different thing. It's what could we do an experiment on that is related to kind of shed more light, not necessarily on the specific RQ that you asked, but maybe a related RQ or something that's closely related, but just how could this experiment be expanded? Is there another little tangent of a direction you could take it off into, or things like that? So we want to mention both ways to improve the experiment that we did, and then possibly slightly new or slightly different experiments to sort of shed new light or maybe get a bigger picture of everything. I know that was a pretty quick run through here, and but look through it yourself. Look through the IB rubric before you start writing, really, and reach out to me with any questions you have if you're not clear about anything. Now, what I want to do right now is shift to talk a little bit more about how to apply this to specifically a database IA especially. So not a sim, not some kind of hands-on experiment you're going to do, but how do we address some of these things in a database IA? So if you're not doing a database IA, then you don't need to watch this last part. But let me just call this up here. Now, I really don't know the best ways to do this. I've always forbidden them in the past. I'm going to do my best with it. We'll work through it and try to figure out how to do this database thing. So, in regards to personal engagement in a database IA, so again, as I said before, don't make up cheesy fake things. If there's some if there's genuine interest that you really had, and it was the reason you chose a certain RQ that you did, then for sure mention it. But as I said before, even if you are doing your research, or maybe you're not finding quite the information you need, so you had to shift gears a little bit, or whatever, you discovered certain things about certain databases as you were looking at them, any modification, any changes you made to the research, definitely comment on that, and that can help get you personal engagement scores. So exploration. So specifically for the database IA, obviously you're not designing an experiment, but what were the choices that you made going from here's an RQ, or here's this maybe broader concept I was thinking about, to a little bit more specific concept, and how did I choose what sources to use, how many sources to use, and things like that. It is possible that there might be some methodology information available to you, some very general stuff. If there is a few general things that you could mention about the methodology that was used to get the data that you were looking at, it might be worth mentioning. It depends on how long it is and how you wouldn't want to include, I guess, a super amount of detail there. So, obviously you're not writing an experimental design, you're not writing a procedure, so it's a different sort of thing. It's sort of the method of your research, if you will. Analysis. So typically in a database IA, there's not going to be so much back-end math and computation that you're doing, but the way you're going to score points on analysis is, did you collect enough data? Did you look at enough sources? Hopefully we're getting some data that's plottable and making a trend line. It's going to be really hard without these trend lines, I think, because making a trend line itself is a form of analysis. We also have to consider uncertainty. So the requirement for thinking about uncertainty doesn't go away. The source might list uncertainties. The source might literally have a plus and minus uncertainty on it. We could talk about uncertainty by comparing several sources. Is there differences between two different sources? If you do any calculations with the data you're getting, you should do error propagation just like you always should. If there's no uncertainties listed, is there some way to estimate the uncertainty, or can we even consider the significant figures that are available, or anything like that? Anything you can talk about related to the topic of uncertainty, you're going to do it. So evaluation. So same as we would with a traditional experiment, we're going to think about our RQ and the research that we did, and we're going to say, what's the answer to our RQ? Do we know an answer to our RQ? Does the information we got actually answer the RQ? And support your stuff with data as you always do or always would. How does it relate to the broader chemical concept? Does this meet your expectations? Now, probably it might be better to make a hypothesis. That's not required, but it might be better to make a hypothesis in a database IA. Like, what is your guess about how this information is going to look before you did it? Is there any way there's systematic error in here? Now, this is going to be difficult with the database IA to know this for sure. Is there anything that could be misleading about the way the data is presented or gathered? For example, is some of your data not actually experimentally determined, but instead calculated from some theoretical thing? Are there differences from a value that's predicted theoretically to one that was actually collected by experiment? These are all things that you could talk about. Improvements is definitely more challenging if you didn't do an actual experiment. But is there a way that you wish you did it differently? If you could start over from scratch, is there data you wish you had access to? Is there other ways you wish you would have thought about it at from the beginning of the way you did the research to the end? Extensions, again, we need to think about, is there sort of a tangential thing that we could talk about that would take this in a little bit of a different direction? So is there a related topic that you could look more into that might shed light on this RQ and again, just the broader chemistry concept? Communication, I don't think that really changes. The communication part of the IA is just presenting the information, titles on data tables, smoothly flowing, using language correctly, all that kind of stuff. I think that's about all I have to say. As I said, we'll do our best with these database IAs, and I'll do my best to help you through it. This is my first time ever having anyone do these, so we're in the same boat. We're going to learn about how to do database IAs together here. So thanks for watching, folks. Good luck with your experimenting and or your researching, and hope to see you in person soon.